Hey, Jody here with weldingtipsandtricks.com. Last week's video was about downhill short circuit MIG welding and some of the concerns with that. That video seemed to generate a lot more questions than it actually answered, so let's continue the conversation. Some of the things that came up were, well, what about downhill MIG welding on a open butt root pass for pipe welds? Good question. It's done all the time. It's a real popular process. In fact, I'm working on a 3G plate test video where I MIG weld, short circuit MIG, downhill root, fill and cap, uphill. Here's a quick peek at the downhill root on that. Here are the specs on this joint real quickly. It's 3/8 of an inch thick. That's roughly 9.5 millimeters. 37.5 degree bevels for a 75 degree included angle. Clean to bright metal. And it's got a 1/8 to 3/32 gap and a slight land on it. Now, this is a perfect scenario where you might be successful going downhill MIG. Clean, bright metal, no mill scale to weld over, and a gap and a nice open groove. Now, the bevels on this plate are 37.5 degrees, which means it's primarily used for practice for pipe. But a lot of pipe root joints are put in just like this, and it works really, really well. And it's really hard not to get 100% penetration through the back side, and you can adjust that with your wire feed speed if you want it to poke through a little bit more. Some other topics that came up in different places on YouTube, Facebook, and places like that were, well, I would have liked to seen you clean at least one of them and weld it downhill. It seemed like you set the downhill up to fail. And I really didn't. Actually, I was very surprised with the results myself. I thought it would do better than that when I cranked the heat up. But that hot rolled mill scale can be pretty tenacious sometimes. If you've ever tried to grind it off, you know that. All right, so this week's video, I'm going to clean a couple of them. Another question that came up in doing this was, well, what if you did two passes where you cleaned the metal and you welded one pass so that the metal didn't flow out in front of you, and then over top of that, we're doing that today also. And then a little bit of uphill welding too, because some people said, I wish I would have compared some uphill to the downhill. So hopefully, again, I'm not going to definitively answer anybody's question today, but this is just some more information and keeping the conversation going, because that's how we all learn. All right, before we get into any new material, let's do a quick review of last week's video. And this was one of the most interesting results of last week's video. One of these joints was welded with a Hobart small, kind of a hobby machine with 024 wire, that's 0.6 millimeter. The other was a thermal arc larger machine, 035 wire, that's 0.9 millimeter. Way hotter settings, but the results were very surprising. All right, like I said, first up here is the small machine with the small wire. You can see the travel speed is quite slow, and you can see it looks a little bit cold, and got a little bit of lack of fusion there in the corner, quite a bit actually. Now the bigger machine, hotter settings, bigger wire, much hotter puddle, but quicker travel speed, and the results on there were actually worse. That hot rolled mill scale proved to be a real culprit. You can even see the rounded edge of that hot rolled mill scale where the molten metal just laid up against it, didn't even melt through it. Well, let's take those same settings and same machine, and now let's clean the metal and weld downhill and see what the difference is. All the mill scale has been removed, and again, I'm using the same exact settings. I'm trying to just go fast enough to stay in the front of the puddle. Makes for a decent looking weld, but still with any downhill weld like that, you kind of wonder if you got all the way down into the root of the joint. So we're going to polish and etch it here, and we'll see exactly how far it penetrated in just about 2 seconds. Not a lot of depth of penetration there. That's very surprising. Even though the metal was nice and clean, down to bright metal, and that acid etch reveals that weld metal, while it may have fused, it may have actually bonded, it just didn't get any depth of penetration at all. It looks almost like a brazed joint. Let's look at that arc again now. This is right about where we cut it. And then let's look at the cross section. Up there in the top, it did a pretty good job of melting that corner, but down there in the root of the joint, near the root of the joint, you actually have a real straight line here. A straight line is the last thing you want to see when you're testing a fillet weld like this. All right, let's turn it down just a little bit and see if the extra heat and wire did actually hurt things, because sometimes it chases you downhill and you think hotter is better, but slowing the travel speed down a little bit sometimes and having the puddle where it doesn't run out in front of you sometimes can actually be helpful on downhill. So let's check that out and throw a little swab etch on that thing. And actually it's quite a bit better than the hotter setting just because of it slowing the travel speed down. That's actually not too bad right there. I see a little A little lack of fusion right in the root of the joint, but that's pretty typical of any fillet weld. Again, a little quick reminder here of what that arc looked like right where we cut it. And there is the cross section. And slowing everything down helped quite a bit. Well, now let's do something else. Let's do 2 passes. Same thing again, clean, bright metal, no mill scale to worry about. And we'll do a pass, good and hot, set up and run it right down the middle. Let it cool for just a few seconds and then come with a second pass. Trying to stay fast enough to stay on the leading edge of the puddle, but that's kind of hard to stay up on the front of that puddle sometimes. Now we'll do the acid etch on this too after a polish. See what kind of results we got here. And actually it's not that much different than we got doing just 1 pass. Now when you're etching, polishing, and all that stuff like this, sometimes you have to get a flashlight or some light source and play the light from different angles to see exactly where that weld nugget is. And see, I've highlighted it right here with certain lighting, and you can see that very straight line right there. So I'm not saying it didn't get some fusion there. It most certainly did, but it's like, again, it's not very robust. You want to see some depth of fusion. Just to be clear, you might be mistaking these areas here for the actual weld nugget, but those are actually lines where it's discolored from the heat affected zone. The lines where I've got the crisscross are pretty much the depth of fusion. It's pretty much flat. Take a peek now at some uphill welding and compare those results, those cross-section results, to what we've seen on the downhill, both clean and not clean. First up, we're just going to weld one with the mill scale on it. I'm going to use this kind of technique here. This is one of many that'll work for uphill, but it's just a series of little triangles where you're tracing the front edge of the puddle and then coming straight across again and keeping that arc on the very leading edge of the puddle so that it has the best chance of penetrating. That looks like this. Again, that's 18.5 volts and only 211 inches a minute of wire with 035. That's 0.9 millimeter wire, ER70S6, using 75-25 gas through all this whole video. Not bad looking, but it's got quite a crown on that weld. Stood up there kind of high. That's not going to be acceptable in some instances. For some, it wouldn't matter. I'd rather have that crown there and have a good weld than I would a nice flat weld that was a caulk bead, basically. So let's swab etch that and get the results. Now, with not cleaning the mill scale at all, just a wipe down so it didn't have any oil on it, tremendous difference. Even at lower settings, that's a good nugget profile. Penetrated all the way into the root of the joint and then some, and didn't just lay flat against the metal. We don't have a braze profile here like we did on the downhill. So that's a lot of depth of fusion. Good penetration into the root. The only problem is the high crown. And once again, the high crown is not always a problem. It just can be if certain codes prohibit that or if an inspector doesn't like to see that. All right, now I'm going to turn the wire feed speed down here a little bit and clean the metal. I know that the crown was a little high, so I tweaked the wire feed speed down a little bit. Same technique again. This time, everything clean to nice, clean, bright metal. And you see I'm even kind of hiding the puddle a little bit with the cup, not intentionally, but I'm just trying to keep my stick out short. And I'm picking up my travel speed just a little bit, but still trying to stay on the very front of the puddle. And that made for a better looking weld with a little bit less crown. Well, let's see what that did. The acid will tell the story. Again, you can use navel jelly, Loctite navel jelly rust remover. It just takes longer to reveal that weld nugget. I just happen to have this stainless steel heat tint remover. And that's a good nugget. So cleaning or not cleaning, vertical up, big difference than vertical down. Mill scale can be different on different shapes. It's going to be different on plate than it is on box tubing, etc. If you've ever tried to grind some of it off, you know some of it you can almost remove with a hard wire wheel. Others you have to get a hard rock in order to get it off, where it loads up sanding discs and everything. So there's different levels of mill scale. This is 1/4 inch plate, very tough layer of mill scale on there. It made a huge difference downhill, didn't make much difference going uphill. Okay, that's it. Stick around and see a few products we got on the Weldmonger store at weldmonger.com.